I had problem 8.83, and it's constructing a 95% confidence interval for the difference in mean compartment pressures between runners and cyclists under a resting condition. And then it's constructing a 90% confidence interval for the same, but who exercise an 80% maximal oxygen consumption. And then considering those and interpreting the results. So looking at it, I did the pooled estimator um formula, and that is like SP squared equals N1 minus 1 times the first sample standard deviation squared plus the sample size of the second minus 1 times the second standard deviation squared over the two sample sizes added and then minusing 2. But in this problem, the sample sizes for N1 and N2 are both 10. So I simplified it to the first standard deviation squared plus the second standard deviation squared over 2. So for the resting condition, the first sample standard deviation was 3.92 and the second one was 3.98. So I squared those, added them, and divided it by 2, and I got 15.6034. And then below that is the formula for a two sample T independent distribution or whatever. So that for the T, I got, because it's a 95% interval with a degrees of freedom of 8, I believe. That might be wrong. Or 18. I think it's 18. So I got 2.101, and then I multiply that by the standard, or the SE. I forget what that is abbreviated for, but it's the SP squared, 15.6034 times 1 over N1 plus 1 over N2. So multiply that all out, you get the margin of error, and that is 3.711. And then I found the point estimate between the first x and the second x, and that was 14.5 minus 11.1, so that got me 3.4. So with those numbers, I found the lower and upper bound. So the lower is 3.4 minus 3.711, which equals negative 0.311, and then the upper is 3.4 plus 3.711, and that got me 7.111. So the bounds would be negative 0.311 comma 7.111. And then for B, it's a 90% confidence interval, so it's the same setup except the first standard deviation standard deviation, sorry, is 3.49, and the second one is 4.95. So doing the same formula, I got 18.3413. My handwriting's awful in that, sorry. So I did the same margin of error, and I got 1.734 for the T value with the critical values and with the degrees of freedom and the 90% confidence. And then I multiplied that by 18.3413 times 1 over 10 plus 1 over 10, the same N1 and N2 again. And that got me 3.321. And then the same point estimate was done by 12.2 minus 11.5, and that got me 0.7. So the lower bound was 0.7 minus 3.321, which equals negative 2.621, and then 0.7 plus 3.321, which equals 4.021. So the bounds would be negative 2.621, comma 4.021. And then for the interpretation, because both intervals, it is possible to have 0 in them, meaning there is no statistically significant evidence between runners and cyclists when they're using a resting condition or an 80% maximal oxygen consumption, because 0 is included in both intervals for the 90% confidence interval and the 95% confidence interval. Why do I not remember?